right, so for those of you who are less technical, let me get a show of hands if you haven't written code in the last 12 months. Show of hands. Okay, great. So for you, I'm going to try to explain this at a level that will make sense to you at the problem level, and this is a little bit more of a technical talk. We're going to talk about orchestration and how NCR, and specifically Shahzad and I and Yirka work together to create a solution for orchestration for the Insight Imports product that Shahzad's team is rolling out. And there were some interesting problems along the way. So, if you fast forward from my story earlier where I'm talking about doing the issue tracker mess, we got into rolling out Chef for our for NCR and hospitality, and it gets to be a little bit more complicated than just rolling out Chef. There's a lot of problems that come up, and we think we found an innovative solution to solve the orchestration problem, and feel like the orchestration conversation needs to be a better conversation than it has been in the past, and we'd like to show you what we've done. So my name is Michael Hedgepeth. I am a senior software architect at NCR. I blog at hedge-ops.com. I blog pretty regularly about culture change and some about technology, some about process and management and chef stuff. And Twitter is at Michael Hedgepeth. And I work for NCR. NCR is the world leader in omnichannel consumer transaction technology. I did not write that, somebody in marketing did. But what that basically means, yeah, I had to sort of read it, didn't I? What that basically means is that 130 years ago, we invented the cash register, and that is an NCR cash register. And that was really awesome for a long time. But in this world today, we have multiple ways that customers need to interact with a retail establishment or a restaurant. And restaurants need a technology partner that they can work with to interact with that, and we are that partner, and we're the world-leading partner for that. So basically, if you've eaten at a restaurant, you went to an ATM, or you flew in a plane, or you went to a checkout, or a retail checkout, you've probably interacted with our technology. Another important thing for the topic is that we are a Chef user. So if you're not a Chef user, that's fine for this conversation. Just substitute whatever you do for Chef, and it'll work just fine. But this started out as an internal presentation, and we just decided to keep it that way and keep it kind of opinionated as to what we do. But this is definitely not a Chef presentation. But it's very configuration management tool agnostic.
Hi everyone, my name is Shahzad Brohi. I am a software engineer at NCR. For the past 5 years, I've been working here on front-end, back-end infrastructure development. And just recently, I began leading the DevOps initiative within my team. So I work on Aloha Insight. And Aloha Insight is a business reporting platform that allows restaurant operators to gauge the performance of their sites. So take, for example, let's say I'm a restaurant operator. I have a burrito shop down the road. I can view my net sales on a Tuesday between 1 to 2 p.m. and see how many burritos I sold during that hour. I can even go further down onto a check for a specific guest, and I can see, okay, they ordered a burrito, it was 20% off, they ordered a drink, they ordered fries, whatever. So there's that level of detail that this application provides. Now, we have this application supports, it's backed by 30,000 restaurants. We have data centers worldwide in different regions. And above all, this is a SaaS application, so it's viewable anywhere, on any browser, any device. Now with that, considering the amount of data we're pulling in, uptime for this application is very critical. Our infrastructure needs to be up. It needs to meet certain time requirements. Our deployment requirements are strict. Yep.
So when we think about orchestration, let me just tell you what that means and kind of set the table for the talk. Orchestration is, you see an orchestra here, you have a conductor. It's when a lot of things need to do something in a particular order. So if you're ever doing an upgrade or something like that, you think, I need to first upgrade the database, but before I upgrade the database, I need to turn off all the stuff because they can't talk to an upgrading or upgraded database. And then after that, I need to upgrade those services and bring them back on. You're talking about orchestration. So configuration management is, we good? Yeah. Mute the what? Okay, cool. Yeah. Configuration management. Yep. That will be my backup. Disaster recovery? Yeah? All right. How far can I go? This far. All right. So we're rolling with it. So where was I? Orchestration. We're talking about orchestration. So configuration management, like what Jeffrey was talking about. How do you make the right services be on a particular machine, or the right ports to be open and closed, run tests on it? That's all good. And then you get to the next level of problem, which is at what order do I do these things? And there are a lot of tools and vendors out there that help you do that orchestration thing. And we're going to argue today, or our point today is that orchestration using a state-managed infrastructure as opposed to a command-oriented infrastructure is much better for a variety of reasons. And so we're going to walk through our thought process, and we're going to tell you a little bit about our solution that we came up with. But first, Shahzad's going to talk a little bit about the architecture of the product that we are orchestrating, give you a little basis for what we're talking about.
So here's a pretty picture to look at. So I'll explain an overview of the process and talk about why we need orchestration. So data gets sent up via FTP from our restaurants to our data center. That data arrives on our import Orleans nodes. And these nodes are responsible for crunching that data and outputting them to an enterprise database. On each of these nodes runs a client service that scans the data and feeds it to another host service that processes the data. Now, the client service finds out about this host services via an Orleans membership database. And we realized that during an upgrade, if our client service was on a different version, if our host services were on different versions, they could not interact with each other. So we had to go the route of shutting down all our services on all our nodes and then upgrading them one at a time, resulting in a very long deployment. So our approach, we need a secure, repeatable, supportable, and easy way to orchestrate the upgrade of a multi-node infrastructure in our data center. First of all, we expect it to work. And by work, we want it to meet our deployment requirements. We want it to fit within our deployment timeline. And we wanted to accomplish the same exact task as if we were to do a manual scripted deployment. Second of all, we want it to mature with us. And by maturing, we want it to scale. So as we add more nodes to our cluster in our data center, we expect the orchestration to continue to work and support a larger scale. And last but not least, we expect it to fit within Chef. And Chef brings the aspect of idempotency, which means that you can execute a recipe multiple times and get your system into the correct state. If even one part of your system is taken, one part of that system is incorrect, you can get in the right state. And plus, it's our primary configuration management solution, and we're very familiar with it.
So we really had three options. And then we're going to talk about our thought process here. We could have made orchestration obsolete, which I'll talk about in a second. That's actually the preferred option. We could use Bash or PowerShell to just script it out, or we could use something like Console and have a state-oriented orchestration mechanism. And we decided that we would use Console by HashiCorp, and we're going to talk through what that looks like because it's a little different than a lot of what you see out there. HashiCorp, if you use Terraform, Packer, Vagrant, Atlas, anything like that, Console is another one of their products. They also have Vault. So they're a really great company, and we found that their tools fit really well with the Chef stuff that we're already doing. And so they're we don't really have a relationship with them. We've never called their support or anything, but we use their tools and we get a lot out of them. So, in February of every year, there is a free conference in Ghent, Belgium called Config Management Camp. If you can get your boss to pay for the ticket, it's a free conference. And it's really great because it's where all of the configuration management tools like Chef and Puppet, Ansible, SaltStack was there, and even CF Engine was there. All of them get together and they stop fighting for 2 days and talk with each other. So you can go to the Puppet track and see what those people are doing. You can go to the Chef track, and so it was really great experience, 2-day conference in Europe that really helped me understand things at a deeper level. And at that conference, Julian Dunn from Chef gave a talk on orchestration, which if you're interested in this more, I highly recommend. And he talked about, he makes a good argument in that talk and convinced me that the best orchestration is no orchestration. And we really want to stress that. This is a cool solution that we have, but really the better solution is no orchestration at all. So let me talk about that for just a minute. When you think about trying to scale a massive infrastructure, the worst thing that you can do for yourself and your sanity is create dependencies in that infrastructure. And so when I talked about if you need to bring all the services down for the database upgrade to bring them back up, that's probably really great. And that's how a lot of tech out there and a lot of tech within NCR is. But what we are moving toward, and what I encourage everybody to move toward, is a microservices architecture that is completely independent. And what I mean by that is your service should be running whether the database is upgrading, whether the database is down, whether the database is up. You should be in a running state, and you should be able to recover from any of those events. And if you have any dreams of going to the cloud, you're going to have to get that right. And there's no tool that's going to be able to stop all this stuff and start all this stuff to get you to a good place in the cloud. That's going to be a path of pain and suffering, because in the cloud things go away very quick, and they come back. They come back very quick, but you cannot rely on an old way of thinking for orchestration. Now the problem with this is he convinced me of that, but I was also immediately convinced that I didn't want to have to go to all my teams and say orchestration is not happening and kind of be a perfectionist about it. Orchestration is not the best thing, so you can't do any configuration management. And so it takes a lot of development changes to get to that architecture, and it just takes time. And there are a lot of benefits to doing good configuration management outside of having this in-state microservices architecture. So we decided that for all of our current products that we were just going to come up with an orchestration model that works for us. The second thing we could have done that's kind of the thing that you think about next is, I'll just script it. I'll write a PowerShell script. And Shahzad's going to talk to us about what we thought about through that.
Right, thank you. So PowerShell, when you look at this script here, I'm sure almost every one of you in this audience can understand what the syntax is. Now, with PowerShell, there are obviously pros. As developers and operations specialists, we work primarily on Windows platforms, and we're used to PowerShell as a scripting technique. Who in this room has not worked with PowerShell? Raise your hand. Okay, so you can obviously tell the vast majority.
There's an alpha version on Mac, apparently. Yeah.
So it's very intuitive. It follows an object-oriented syntax, similar to a lot of programming languages. And obviously, with that, there is less of a learning curve. It's quite easy to pick it up and use it for automation. But with that, just because it's easy doesn't mean it's the best solution. There are some cons. First of all, it's Windows only. And at that time, we were looking at just automation for Windows infrastructure.
Yeah, and another con is that it can be script dependent. And this, if you want to get this point, you got to pay attention. I'm sorry. But when you think about it at the beginning, you're like, okay, I'm just going to write a script. Script's going to bring down the services. Script's going to upgrade the database. Then the script's going to bring up the services. Bam, I'm done. I wrote a script, Bash or PowerShell, whatever it was. Great. And then the next release comes around, you do it all over again, great, you're happy. But the reality is there's a lot of things that happen between those two events. Like, what if you want to add a new machine? Is that machine running a script? What's it doing? It's probably doing something different, and that different thing's probably not tested. What happens if you bring a machine out of your cluster or that it was rebooting, or what its network was down and it didn't get any of the script commands and it forgot to upgrade? What is it going to do? It's probably going to sit there and cause havoc. It's going to be an unplanned chaos monkey for your infrastructure. So you don't want that either. So the script thing, the problem with it is it creates this wide gulf between your version releases that you cannot really do configuration management within because you're too scared about the orchestration stuff. And that is the main benefit that we get from the next thing.
And to add to that, Chef is unaware. With just the scripting approach, like I mentioned before, we're not leveraging idempotency, and we can't continuously run a Chef recipe and restore the system state as we expect it to.
Yeah, and this is something that happens with some teams if they don't have a lot of coaching with configuration management. And a warning for you if you're starting, a lot of times you can write configuration management like a Chef script or Puppet script, whatever, like it's a bash script. So I've come across this, like somebody's like, I have my Chef script, let me see your Chef script, and it's just this big PowerShell script within a Chef script. And that kind of missed the point. That's great that you're running Chef, you can put it on your resume. I highly recommend that. But then if you're just doing it to run PowerShell script, PowerShell has already solved how to run PowerShell scripts without Chef. It's a thing. You could just run a script, and it's easy. What Chef gives you is something else, and if all we're doing is running Chef just for the scripting mechanism, we lose its power for managing configuration on machines. So what we came up with is orchestration through console with HashiCorp, and we really like this model. We really like console the product for a couple of reasons. The main thing that it gives us is this shared system state that we can interact with throughout our infrastructure that's real time. And so we'll use a metaphor with this. It's kind of like a football team. So doing orchestration the script way, where you say, bring the services down, upgrade the database, bring the services back up. In a complex situation, it's kind of like a receiver's coming into a football game, and you say, okay, receiver, here are all the plays that we've ever run. Starting with the first play, we did a kickoff. Then we're going to play this play. And the receiver's nodding, yeah, okay. And then now we're doing this play, go. Okay, that's a very complicated operational environment for a football team and patently ridiculous. But instead, with a shared system state, all you have to do is focus on the current play that's called. All right, receiver, right now, our services are in a stopped state. This just changed about 10 seconds ago. So now that you're joining this game, be in a stopped state. It's easy. You know how to do that. And everything else that you normally do all that too. And so people can go in and out of this of the game, and they can read a shared state in real time that is changing very, very quickly. They can join in that and leave, and it's a very simple operational model. So Shahzad is going to talk to us about the basic architecture of how we are running console.
Thank you. And so this is our football team, basically. So we begin with a set of console servers, and they serve the purpose of hosting a key value store, and that's managing the shared system state. And you can relate that to the playbook on a football team. Now, in our case, this shared system state is metadata about our deployment, and this consists of the target upgrade version we want our cluster to be on, and the target Orleans membership database we want our cluster to be connected to. We have an orchestration node, and you can think of this as a quarterback on a football team. It writes information about our deployment to that shared system state using an access control token. It is the only one that can manipulate that state. It's a single node. And similar to that, we also have our application nodes. And as I referenced earlier, these are the nodes running our host and our client services. Using the same access control token, they read that shared system state, and they obtain information about what version they need to be on and what their current version is. And then based off that criteria, if there's a difference in version, they kick off the Chef client process, execute the upgrade to the new version, and join the New Orleans membership database.
Yeah, and the access control was really important to us. One of the other things that happened when I was in Ghent, I went to the Salt. Does anybody use Salt? Yeah, it's pretty awesome, right? I went to the Salt. Salt's a really great tool. I went to the room. One of the things that scares me about Salt is that you can make root level changes on anything in your environment at any time without any planning or evaluation beforehand. But other than that, it's awesome, right? So, and I raised my hand. We had a few minutes. I raised my hand, and like, does this scare anybody that you can make root level changes, so you can just change anything you want with which is a single command in your infrastructure immediately and basically bring it down? And the guys in the room were like, no, it doesn't scare us at all. But that's not how we roll at NCR. We have financial transactions. We have to be PCI compliant, and things have to be controlled. And so being able to say, this orchestration node is the only thing that can update the playbook. The coach is the only one calling the plays. And if I know the play got called, I know through console's access control that it was the orchestration that was the only one that did that. And so that simplifies the operation. It wasn't somebody running a command somewhere acting as that or going to the UI and updating some stuff. It's a really safe mechanism. So the other thing console gives us that we think is cool, and frankly we're at the very early stages of taking advantage of, but I think it's going to be big for us, is the service discovery and remediation aspect of it. So what this basically means is, like, if you're running in the cloud and you got stuff coming in, you got stuff coming out, you're going to have a mechanism for figuring out who is what. And in the old days of emailing somebody and saying, add node X to the web server, are over at that point. You have to have a better mechanism for doing that. And consoles are really nice for that. It allows you to be able to name your servers, like this one's a web server, this one's the database, and use either DNS or straight right into config files to tell your applications which servers are the database and which servers are a service X. So that was really great. The other thing it does is remediation in real time. So if your service degrades, it knows that, and it can restart a service in real time. So what Chef gives us, it gives us configuration management kind of in periodical time, like every 30 minutes or whatever. And then console gives us the real-time configuration management at that micro level of being able to discover services and reboot services. And the thing that really was attractive to us is that it fits very nicely within what we were already doing with Chef. So Chef is driving the ship. Even Chef's driving the console ship. And then console's doing a lot of cool stuff. But Chef's really the same mechanism, the single mechanism we use to configure our machines. So we're going to talk very briefly about what we came up with for console in our journey. Our old plan was to have an outage and only use Chef at the upgrade. And after talking to Julian, I realized that maybe there was a better way. And I talked to the lead developer in Prague after that Belgium trip. And I said, well, how do people do this with zero downtime? And he talked to me about Halo. Does anybody play Halo? I don't play Halo. I know it's a cool video game. But he said that Halo uses the Orleans infrastructure that this product is built upon. And they basically use a mechanism where they build a new cluster, migrate everybody to point to the new cluster, and then blow the old cluster away. Like that's their plan for dealing with the orchestration needs. And we couldn't do that because we're at a private data center without being able to build a bunch of machines rapidly at the moment. And so we use this approach.
Right. So we drew inspiration from that model. They would build a cluster in Azure, take it apart, and we needed to apply it to our own data center. With that orchestration approach, there are several main phases. And before I get into those phases, let me give a brief background on our cluster setup. In order to have an orchestrated approach, we have to have a primary Orleans membership database that's our existing cluster in production that's running. We need to have a secondary Orleans membership database that we'll eventually migrate our services to during the upgrade. The first phase is to divide our machines in half. Divide in half, what does that mean? Well, we have 2 services running on each of our nodes in our data center. Let's say we have 40 nodes. We need to basically put them into 2 halves, 20 and 20. And to better illustrate that, here's some code to look at. The first and most important thing is to get so right here, this is the orchestrator recipe. This runs on the orchestrator node, and this drives the entire orchestration. The first thing to look at is the policy version. The policy version represents our target upgrade version, and this is the version that's taken out from our build process. The cluster state, you can see slightly below that, is the current state of our cluster. And this state consists of the current version all of our services are on, and the current Orleans membership database they are all a part of. Now, in order to perform the orchestration, we compare the version our cluster is on versus our policy version, the version we want to upgrade to. And if they're different, we will then divide the machines in 2 halves. Now, once we divide those machines in 2 halves, we need to identify what our target Orleans membership database is. And this alludes to the cluster references I mentioned, primary and secondary. If we're currently on the primary, our new target upgrade is going to be the secondary and vice versa. As you can see that here. The next phase is to migrate half of the nodes to the new cluster. Now, this is done via one single orchestration step, and it accomplishes 2 different things. The first thing is that it writes our target upgrade version, target Orleans membership database, to the key value store. Then it actually kicks off the Chef client on all of our nodes in that half, and the Chef client process reads the system state from the key value store, gets its target version, gets its target database, performs the upgrade. And in order to do that, this entire step waits for the Chef client process to complete before moving on to the next step. Next phase is to migrate our clients. And these are our services that feed data to our host services. At this point, we have a primary cluster that's still running, and half of our nodes have been moved to our new cluster. And similar to the first step, this orchestration step writes the target upgrade version, Orleans membership database, to our key value store, kicks off the Chef client again, waits for it to complete, and that thus migrates our clients over to our secondary cluster.
Yeah, the thing we really like about this, we've already done this model with 3 of our products, and we really like how simple it is to declare it, and that's kind of a power to configuration management or something like Chef, is that it's very easy to read through and understand what's happening, and there's a lot of cool things going on in the background that we wrote.
And with that approach, now at this point, we have our new cluster up and running and our second cluster deprecated. But we still have our host services that are running there, so now we're just going to migrate the rest. Once again, we kick off this step, take our second half and migrate it to our new cluster. And now we're up and running, our cluster's on the new version, and through this entire approach, we have had 0 downtime totally. So now, where are we in the journey? So far, we have been able to prove out this concept in our internal QA environment and demo in front of internal people. Next, we're going to roll this infrastructure out to our production server farm, which is going to be a large-scale farm, and that's where we're going to use orchestration. Now, there are 2 takeaways, 2 important takeaways you guys can get from this. The first one is that scripts may be intuitive, they may be simple, but just like the football analogy, to get your system in the right state, you have to run all of them at once. And you have to run all of them for new nodes, adding new nodes to a multi-node cluster. With shared system state, it's much easier to add a new node to the cluster. It reads the information from the shared system state, it knows what to do.
And then my takeaway, hopefully, for this is, if you're starting this journey, you're kind of probably looking for some sort of automation. You'd probably start with scripting like PowerShell or Bash, whatever. And then you graduate into configuration management, Le Chef, Puppet, Ansible. But also be thinking about shared system state and the role that should play in your system. And think about how there might be a better way than doing just writing a quick script to do things when you're thinking about making something operable in the cloud in a real operations. Some investment up front into giving you a more simple infrastructure later on will pay back dividends. Thank you guys very much.
Thank you very much.